All right, now we kind of touched on this previously as well, but if you have a couple of vectors, x, y, and vector v is x, y, and vector w is rs, you can sum those vectors. X, y plus rs would be the horizontal component would just be adding the horizontal components, and the vertical component would just be adding the vertical components. A difference, so v minus w would be xy minus rs. And once again, that would just be subtracting. So it would be the horizontal of v minus the horizontal of w. And for the vertical of v minus the vertical of w. And for scalar multiplication, well, you just distribute whatever the scalar is to each of the components. So a scalar of m times vector v would be mx, my. Alrighty, so like I mentioned before, this is often a little bit easier to work with if we do it with linear combination form instead. So they're going to give me vectors that are in component form, but I'm going to rewrite them in linear combination form and then use that in order to do all of my operations down here. So I'm going to start with that. I'm going to rewrite S is 3i plus 5j. And w would be negative 6i plus 1j, so just j. And then u would be 7i minus 3j. Okay, so now when they ask me to do something to find this new vector called v, then I'm going to use these linear combination forms to do that. So for my first one, vector v is just the sum of s and w. So I'm going to start with that. S is 3i plus 5j. And then I'm going to add to that. W is negative 6i plus j. Now the really nice thing about this is even if you didn't know that I and j represented horizontal and vertical unit vectors, you would probably be able to find the answer for this one just with what you know about algebra. The parentheses, because you're just summing two binomial expressions, the parentheses don't really have any bearing there. You could ignore them and then just combine your like terms. So 3i plus negative 6j would be negative 3i. And then 5j plus j would be positive 6j, so plus 6j. So this new vector would be negative 3i plus 6j. If you did happen to need it in component form, getting it from this form back to component form, of course, is very easy. So I could say, well, that would just be negative 3, 6. That's my vector v. Okay, looking at the second one here now, we want our vector v now to be a difference of u minus w. So once again, I'm going to start with just a substitution there. So vector u in linear combination form is 7i minus 3j. And then vector w is negative 6i plus j. And then once again, from there, I can rely on my algebra skills. So this time I know I can't just drop the parentheses and pretend like they weren't there. I would need to distribute that minus first. So I'm going to go ahead and do that. Oops. That was supposed to be a minus. Okay, so 7i minus 3j, and then minus a negative 6i would be plus 6i, and then minus a positive j would be minus j. And then finally, we just need to combine like terms there. So 7i plus 6j would be 7i plus 6i would be 13i, and negative 3i minus, oh my goodness, negative 3j minus j would be negative 4j. And so that would be in linear combination form. If I needed it in component form, that would be easy enough to do. There we go. Okay, one last one here. If you feel like you know what you're doing here, you may want to pause the video and see what you can do with this last one before you see me work it out, and then come back and see how you did. So I'm going to say 2 times vector s. So I'm replacing s with 3i plus 5j, that vector in linear combination form, and then plus vector u, linear combination form, that's 7i minus 3j. Okay, now with this one, before I can do the addition, I have to do the scalar multiplication. So I need to multiply that 2, and that 2 is only being multiplied by the vector s, the 3i plus 5j. So that first one would become 6i plus 10j. The second vector is unaffected by that 2. So that one just stays the same. And I can get rid of the parentheses now because it was a plus sign before those, before the parentheses there. So now I can sum my like terms, or my like vectors there. So 6i and 7i is 13i. 10j minus 3j would be positive 7j. So this last one would be 13i plus 7j. In component form, of course, that would just be 13, 7. All right, now you try the rest of the problems.